Good afternoon. I'm Caprice Moore, Interim Vice Provost for Global Learning, and I'm happy to welcome you to S&T's Global Learning Spring Speaker Series lineup. This afternoon, we have the pleasure of hearing from Dr. Dave Westenberg, Professor of Biological Sciences here at Missouri S&T. Dr. Westenberg will speak to us on a timely subject that addresses the origination and shared environments of infectious diseases in his presentation titled Epidemics in a Connected World. This will be an engaging 30 minutes, so feel free to post your questions in the chat, and Dr. Westenberg will answer as many as possible in the allotted time. Dave, thank you for being here. The platform is yours.
Thanks, Caprice. Good afternoon, everyone. Welcome to our presentation. Let me see if I can get everything up and going here. All right, so I'm here today to talk to you a little bit about epidemics in a connected world. Kind of a little bit a follow-up of some things I've been doing for the last couple of years here to kind of communicate with the general public about infectious diseases. And just kind of a little plug, this presentation goes along with my role as a Presidential Engagement Fellow. I'd be happy to come and talk to your group, your classroom about this topic, as well as some other topics I have available. If you'd like to see about what myself and other Presidential Engagement Fellows have to present, there's a link below, or feel free to reach out to me by email. Here's my email address. Just let me know and I can get you in contact with how to get an engagement fellow to come and talk to your group sometime, either virtually or hopefully someday in the near future in person. All right, so thank you again for participating. Let's get into the subject of the day. So infectious diseases have been with us throughout recorded history. This is a stele from an Egyptian stele from 1400 BC that is thought to depict a man with polio. And so there's been record of infectious diseases impacting humanity throughout the ages. And of course, these infectious diseases resulting in outbreaks, pandemics have had a devastating impact on society. The death toll of infectious diseases over historical time has just been tremendous. And what we have to kind of realize though is what we often focus on is this impact of how many people died from a particular epidemic. And what we often overlook is the impact can go well beyond just the number of people that succumb to these diseases, but the impact on our quality of life, other things can be just as devastating on society. And what I'm going to do today is kind of as a backdrop to where we're going, kind of a little bit historical perspective, and touch on some of the important aspects of infectious diseases that I'd like people to be aware of, is we're going to focus on this, what's been called the Spanish flu. And hopefully I'm going to change your mind about referring to it as that. But that's kind of what led to a lot of the presentations that I've been putting together in the last couple of years. And a lot of this revolves around a fabulous exhibit that the Smithsonian put together, the National Museum of Natural History, put this together to commemorate the 1918-19 influenza pandemic, which many of us call the Spanish flu. And so this is a project together with the American Society for Microbiology, and I've been very involved in ASM and their outreach activities, and putting this together, and then talking to my colleagues at ASM, learned that what the Smithsonian had done is actually created a DIY version of this. And so what I did in spring of 2019 was put together a traveling exhibit of this Smithsonian exhibit. And I want to let people know that I'm happy to share this with anyone in the region. I have 17 panels available, and I'd love to see this used in all sorts of different environments. In spring of 2019, we put this on at the center here in Rolla. But if you're interested, let me know, and I'd be happy to work with you to exhibit this in any place you'd like to share. But my presentation today, a lot of this is going to be built around this outbreak exhibit, and I'm going to include some of the panels in my presentation. So a lot of the material comes from this exhibit. I also had the pleasure of working with another Smithsonian exhibit that we did here on campus that the on commemorating World War I and some of the lessons learned from that. So I also, in fall of 19, gave a presentation on some of the lessons learned. And so that's going to kind of be a feeder to some of this material as well. So let's go ahead and talk about some of this information. So what is it about this 1918, 1919 influenza pandemic that has been kind of guiding us for many years now in how we look for and deal with infectious diseases? And so what we know about this outbreak was that it killed nearly 750,000 Americans. Around the world, the impact is thought to be anywhere from, I've seen estimates as high as 100 million people around the world. But most estimates you're going to see are 30 to 50 million people around the world that died during this pandemic. And so this in the US was a death rate of almost 4 people out of 1,000 were killed from this disease. And it peaked primarily in October of 1918, so we generally think of it as a 1918 pandemic. But this actually came in waves that spread out from 1918 to 1919. And the virus itself in different forms has stayed with us for many years after that. But the real true impact on society was really over the span of about a year and a half. And what was unique about this epidemic was the fact that it generally focused on healthy young adults. 20 to 40 years of age died during this pandemic, which is very unusual for influenza, which typically affects the very young or the very old who tend to be at greater risk. But these healthy young people dying of this disease was, again, very impactful. And you can see this in what happened to life expectancy in the US, which declined by 11 years. Now, that's a pretty major impact on our society. And so what it looked like during this time period is it, again, kind of came in waves with this peak in October of 1918. But it began really in the spring, and that's when things really started to catch our eyes. And then the second wave hit us in spring of 19, and that was our impact. So you got to ask yourself, where did this influenza come from? You know, what led to this outbreak? And as like any good Missourian, we blame Kansas. In all seriousness, though, what we really have to think about when we talk about these infectious diseases and where they come from is we really have to get away from this blame game. You know, where did it come from? Who's responsible? Where is responsible? What we find is there's a lot of information that we're never going to have a firm answer on what these things are. And what we really have to do is focus on the impact on the population. So let's look at Kansas in this spring of 1918 and focusing on this region called Haskell, Kansas, southwestern Kansas. I love this description from a book that fed a lot of the information I'm sharing with you today, a great book called The Great Influenza by John Barry. Highly recommend reading this. Gives a lot of impact on perspective on what healthcare was like in this time period and why people had the perceptions they had of this disease. And Haskell, Kansas was just a classic small rural community where people raised, grains, poultry, cattle, and hogs. I'm going to focus on that poultry and hogs side of this equation. But this was Haskell, Kansas, a classic, rural agricultural community. And of course, World War I came along, and Haskell County went to war just like everyone else around the U.S. And most of the people in this community went to Fort Funston, now Fort Riley in Kansas. And so people traveled to Fort Funston back and forth. And what they noticed in February, spring of 1918 was that a lot of people in the county were suffering from La Grippe, pneumonia, the flu. And this was reported in the local newspapers that, just typical small town newspaper, Harry's, not feeling well, so everyone's down. It was great to see the soldiers coming back and visiting the community. But unfortunately, at this time, this influenza then started to spread. And what we saw in Camp Funston, that people started coming down with the flu. More than 100 soldiers succumbed. And within a few weeks, this can quintuple. So the impact on the military camp here was quite surprising. Again, these are typically young, healthy individuals. They generally aren't as severely impacted by something like the influenza. And so this was a remarkable element of this disease. And an important player in this part, and why we tend to focus on Haskell County, Kansas as the source of this this outbreak, was a physician, a classic country physician, Dr. Loring Miner, great name, right? Dr. Miner, who was a classic, country doctor. As they say here, epitomized what we view as the country doctor of this time, not trained in the scientific ways that his son was trained in, but still he had this love and passion for the arts and the humanities. But he was also, again, understood this scientific aspect. And so he actually had the sense to report this to a publication at the time called the U.S. Public Health Service, a precursor of what we now call Morbidity and Mortality Weekly Report, published by the Centers for Disease Control. And so he published that there's something strange going on here. We're seeing cases of young people that are succumbing to a disease that is devastating, much more than any other influenza outbreaks we've seen before. And so that kind of got the word out that there's something happening here. So then the question is, well, why do we call it the Spanish flu? Why don't we call it the Kansas flu or whatever? And the interesting thing is that, we're talking about World War I. Most countries involved in World War I didn't want to have an impact on morale. So a lot of the newspapers didn't report on what's going on. Maybe the local reports might say something about, someone's under the weather, they'll report some basic information, but not a lot of information. But Spain was neutral. So they reported extensively what was happening at this time. And interestingly, in Spain, they were referring to it as the French flu. My understanding is they also referred to, I can't remember now, I should have written it down, that there was a dance popular about Naples. They also referred to that terminology. So Spain, because of neutrality, they were blaming other people. So we tend to always look for someone to blame when we have these kind of outbreaks going on. But we learned a lot of lessons from this outbreak. Number one is this is an outbreak that really impacted everyone. And the tendency up to this point was to blame people and their circumstances as a reason for why an outbreak was happening. We realized that these things can impact really anybody. And what we really needed was some kind of a centralized public health service to manage these diseases. We need to have a reporting system to keep an eye and monitor and let people know when these things are happening so we can act quickly and prevent them to get into that point. And so that led to precursors of what we now know as the World Health Organization. We began to recognize that epidemiology is an important science that we really need to focus on. But you might ask yourself, well, what about vaccines? Why wasn't that an issue? And what you have to realize is vaccines really only kind of became a significant part of our arsenal until the 40s. We didn't even know about the influenza virus until the 30s. A lot of the research at the time when the outbreak was happening, there was a lot of focus on bacteria. There's a bacterium out there, influenza, now I'm twisting my tongue, mycoplasma pneumonia. All right, I'm getting myself. Haemophilus influenza is the organism, and it got that name because people early on thought that it was the cause of influenza. So the capability of recognizing viral diseases was not well known. So vaccines are a very powerful tool, but it wasn't in our arsenal. We had to learn how to recognize these things and deal with them. And so the influenza has always remained in our mind as an important infectious disease that we monitor very carefully. And so we've had several scares over the years. We had an Asian flu pandemic in the 50s, Hong Kong flu in the 60s, swine flu in the 70s, avian flu in the 90s. We had H1N1 in 2009. So for many years, influenza has always thought to be, that's going to be the next big one. We were expecting a major outbreak of influenza. An important thing to keep in mind here is, again, notice the names that are given to some of these. Right? The swine flu, the avian flu, the connection here to animals and their role in this process of how diseases come about and where they impact us. But let's take a step back to the 1918-19 flu. Why was it so deadly? How do you learn about these things? And what's really fascinating about this virus is some scientists went and came up with the idea, let's look at some people who died from this outbreak and exhume the bodies and see if we can isolate the virus. And sure enough, they went to Alaska where the bodies had been frozen. They were able actually to grab some tissue and isolate the virus. And an important observation here was to discover that it looked like it actually was an avian influenza, not swine. Early on, we always calling it the swine flu. Another name for the Spanish flu was the swine flu. And that's what scared us in 1976, expecting this swine flu pandemic. But what they realized from this investigation was this avian origin. And that's, again, an important thing about these infectious diseases, the animal connections that might come from that. And so like any good scientist, they actually then recreated this virus in the laboratory and they tested it out, and they were able to actually infect animals and show that it led to a response we call systemic inflammatory response syndrome, something called the cytokine storm, which you may have heard referred to oftentimes early on in COVID. This is what the devastating impact of this virus was on people, was what it did to our immune system and our overreaction. So we learned a lot of lessons from the 1918-1990 influenza pandemic. We're hoping that would lead to how we respond to any future pandemics. But as we've learned in recent times, that as much preparation as we have, we're not always prepared as we want to be. And so we always have to keep looking forward to what can we do to be aware of and monitor when the next outbreak may come along. So again, let's get back to where do these pandemics come from and what can we do to better prepare ourselves? And so this is where the outbreak exhibit comes in handy. And a concept that we all need to be aware of, we call One Health. One world, one health. And realize how connected we are between the human population, our interaction with animals, and our interaction with the environment. And try to find ways to recognize what may be potential causes of infectious disease, how to monitor them and stop them before they get out of control. And we have to realize, again, through this connection, we have to think about what aspects of the human condition make us more susceptible to diseases. What is it about how we raise animals that, again, raise our risk of infection? And what are we doing to our environment that's going to increase our contact with animals, particularly wild animals, and what we can do to prevent that? But this animal connection has always been with us. Most infectious diseases are what we call zoonotic. They originated with animals. And as long as humans have been domesticating animals, we've been exposed to these diseases associated with the animals. And what we also know is that there are certain animals that tend to be greater vectors of these diseases. They serve as reservoirs that retain these viruses in their populations and bring us at risk when we interact with these animals. And so what we're talking about here primarily were events we call spillover events. When the infectious agent enters into the human population, most times, fortunately, it doesn't get very far. It happens, they're monitor events. I monitor a program called ProMed Mail, and I get daily reports of outbreaks. And these outbreaks are happening all the time, all over the world. That's why we can't blame one area. These are happening all the time. It's just that once in a while, through sheer bad luck, they get to humans and they can transmit with humans. And then it becomes an outbreak where it happens at a large level in a small region. And then unfortunately, those outbreaks can lead to epidemics, a more widespread, or even a pandemic, a global spread. And so what we want to do is try and prevent these things at the level of an outbreak so they don't get to the epidemic or the pandemic stage. But that's a huge challenge to do that. And we have to make all the efforts we can to try and minimize these things. And so simple actions are often what it takes. Minimize our interaction with animals, particularly wild animals. Use insect repellents to minimize the chance of vectors. Simple things like washing our hands, getting vaccinated when it's available, staying at home when you're sick, using medicines when it's appropriate. So taking common sense precautions can be invaluable. And when we have a chance, do what we can to really stop this disease when it outbreaks and cooperate. We need to communicate effectively about these things that are happening. And that's what I'm hopefully to get across here is how can we better communicate and listen and dialogue about what's happening so that we can keep track of things. How do we monitor what animals are potentially at risk? How do we monitor when it gets into certain water supplies? And then once they are out there, how do we get surveillance going and let people know what's going on? And what we can see are a lot of great success stories. We've learned a lot of lessons, how to get the community involved, how to equip laboratories, how to properly budget this. And a great story, and I'll recommend a movie called 93 Days out of Nigeria that describes the more recent Ebola outbreak that almost risked getting into one of the most populous cities in our world, in Lagos, Nigeria. But through a good response system, a monitoring system, good public health care, they were able to minimize the impact of what could have been a devastating Ebola outbreak. And I say this movie, 93 Days, does a great job of presenting this whole concept of what's going on here. So I recommend taking a look at that. And then before I wrap things up here, I also want to be aware that we have a lot of other threats out there. As a microbiologist, I'm really concerned. This is what bothers me, is I'm concerned about the growing increase of antimicrobial resistance in the population. So when we talk about these outbreaks, these viral outbreaks and pandemics get a lot of attention, but there are a lot of things going on in public health that we really need to be careful. And I think this, to me, is the next huge story, is monitoring and seeing what's happening in the area of multi-drug resistance and the bacteria that are becoming resistant to the drugs we have available to us, and how do we minimize those types of things. So that's some ideas, some history from my perspective on infectious diseases. And I'd love to know, what would you like to know more about? What questions do you have that you'd like to try and talk about and share with me? So I'll turn it over to your questions and see where it takes us.
Great, everybody. If you do have a question for Dr. Westenberg, just please put it in the chat, just so that we can all see the questions and read them at the same time. There you go. Okay, we have one here that says, what do you think of the theory that the 1918/19 influenza originated in France?
Great question. I don't think we'll ever fully resolve that. You know, a lot of it, again, it's your perspective. You know, like I said, in Spain, they blamed it on France, you know, because that's where they saw it coming from. And so we tend to, again, focus on where our perspective is. When it happened in France, it looks, again, the evidence I've seen really seems to make it come from the US. You know, whether it was in Kansas or somewhere in the US, that just seems to me to what makes the most sense. But I've seen someone reach out to me that did it originate in China. You know, a lot of infectious diseases kind of come that route. And it's not because there's anything about China, it's just that's the route of migration of birds. And a lot of these influenzas are bird viruses. And so a lot of it's not the source of the country or the people. It is the organisms, those vectors that are transmitting it. And so, so whether it came to the U.S. first or got to France, just to me, the evidence seems to point mostly to the U.S., but it may have come earlier than that. But what we also know is that the virus evolved. You know, it may have started in the U.S., but evolved into a more devastating virus over time as well. And so when did it evolve into a more devastating virus? That's the other question that we can have. So what do we really call the true origin?
Okay. Your next question is, so would you say that COVID-19 is just another one of those pandemics that'll eventually pass, or is it a lot more dangerous compared to the others?
Yeah, that's a great question. Where are we going to go with COVID? And I think, you know, from what I'm seeing from my colleagues in this area, I think the virus is with us for a long time. But we can contain it. We can control it. We can the virus can become what we call an endemic virus. It's not going to lead to large outbreaks, but it's going to be with us for a period of time. A lot of people early on were suggesting that this virus is going to eventually evolve into a weaker virus. That's possible, but the thing is, we need to remember that evolution is not intentional. Evolution is purely random chance. And a virus could evolve to be weaker. A virus could evolve to be more strong. So we can't predict what the virus is going to do. But if we follow good public health measures, if we get a good effective vaccine, this virus is eventually going to work its way into a situation where it's going to be less of a severe consequence. That's my opinion on what this is, where this is going to take us. But I'm pretty confident that that this virus eventually will be somewhat, if not contained, at least to the point where it's not going to have the devastating impact it's currently having. Others you'd like to touch upon there? Which one shall we handle next?
Dave, I think there was a next question from Amy Branch.
Sorry.
She said that her Project Lead the Weight class is watching human body systems.
Sure.
And they were curious about what animal did COVID originate from?
That's still a question. We can't say with any certainty. It's certainly from what the genome sequence of this virus looks like. It's quite clearly it originated in bats at some point. But was there an intermediate animal? We can't say. But we just know that bats harbor these viruses quite regularly. These coronaviruses. And the similarities to some of the bat coronaviruses is undeniable. But we don't have a bat virus that's close enough that we can say with any certainty that it came directly from a bat to humans. We don't see that quite transition. We see the same thing when we looked at HIV. When the AIDS epidemic struck us, a lot of similarities between HIV and simian virus. Simian immunodeficiency virus. And so it looks like it came to us from apes in that particular case. But there was no real direct evidence when that transition happened. And so I think we're going to say the same thing with COVID-19, that it likely originated in bats at some point. And another important part about these zoonotic viruses is for some viruses, the animal reservoir is a constant source of the virus spilling over into the human population. I think that's what we're seeing with Ebola. Ebola has an animal host as a reservoir, and infrequently the virus spills over into humans and then it spreads within the human population. COVID-19 seems to be a one-shot deal. A spillover event happened, the virus evolved to adapt to humans, and now it's within the human population. That's pretty rare for a virus to spill over like that and then become quickly spread within the human population. We see a lot of cases where it jumps into humans, but doesn't spread because the virus is adapted to that animal. It's not adapted to humans and has to go through significant evolution to do that. That's why the original SARS epidemic in 2003 never really took off, because human to human transmission wasn't very significant. The avian influenza in 1997 never really took off because it wasn't easily spread among humans. Something about this COVID-19 virus managed to get into humans and stayed in humans and rapidly spread among humans. So that's a long answer to a short question, but to me, it originated in viruses, but whether it was a direct spillover, it's hard to say. Thanks for the question. Thanks for watching. Glad your class is joining us.
Sylvia, do we have time for a couple more questions?
Yeah, as long as Dr. Westenberg doesn't mind staying on. We have this scheduled until 12:30, but if you need to drop off, that's fine. If he's still interested in answering a few questions, we can continue on.
Oh, I'm happy. I'm not going anywhere.
Perfect.
Okay.
So we'll just, we appreciate those that joined us. And if you do have to drop off, thank you. We have several more coming up. Please check out our website. Speakers, I'll put it in the chat. And thank you.
Yeah.
So go ahead,
Okay,
Michelle.
Thanks.
Okay, our next question is, did all of the viruses evolve and change into other strains? And do viruses weaken when they evolve?
Great. So every living organism evolves. That's life. Everything evolves. and that's just the way living things work, because mutations are always happening as the way things replicate, as they produce DNA for the next generation. And viruses, if their RNA gets reproduced, mistakes are always made. So every living organism evolves. And yes, I'm calling viruses living organisms. That's sometimes a debate we have in microbiology. Is a virus living or non-living? I like to think of viruses as acellular life. And so all viruses evolve, all bacteria evolve, all humans evolve. And then this idea of, do they evolve to be weaker? We can't predict. Evolution is random. It's not a directed trend unless there are conditions that kind of direct it to go in a particular way. But evolution is just random chance. It's changes happening over time. In general, though, it's easier to screw things up than it is to make things better. So generally, when any organism evolves, it acquires mutations. It's a greater chance that those mutations are going to make the living organism less effective at what it does. But that doesn't mean that it can't get better at what it does. And so in general trends, living things, viruses, are going to generally evolve to be somewhat weaker. But at the same time, they can get worse. We can't say with any certainty. But the reason why they tend to get weaker is again, selective pressure. You know, if you're a virus and you kill your host off right away, you're not going to be very successful. But if you can infect a host and keep that host alive to keep making more copies of you, you're going to be more successful. And so those are the kinds of selective pressures that can act upon living organisms that evolve. But generally, we can't say with any certainty if they're going to get stronger or weaker. We just know that they're going to change. And we just have to hope that that change is slow enough that we can monitor them.
Good deal. You mentioned Ebola was contained. Why was COVID not contained? What is the difference in strategy?
Great question. Ebola was contained, a lot of it because the public health measures that were implemented were very effective. We have a good understanding of how the virus is transmitted, and it's really a very hard virus to get. Ebola requires a very specific route of transmission. You know, it has to be transmitted through bodily fluids, typically blood. COVID is transmitted through fine droplets. And so it can be easily transmitted in the air. Early on, I will confess, early on in COVID, I did a presentation and I was hesitant to recommend mask use because the evidence early on wasn't convincing yet if it was an airborne or transmitted through the air like it is. But now that we know that it's transmitted through the air, I am very adamant about mask use, not because I think a mask is going to protect me, but to prevent it from transmitting to others. And so a virus like SARS-CoV-2, the virus itself, viruses like measles are very, very easily transmitted. And so when something is easily transmitted, it's hard to contain. Ebola is not easily transmitted. Ebola is transmitted through bodily fluids. And so if you could minimize the exposure of close friends and family to bodily fluids, the greater risk. The real tragedy about Ebola is, I heard this described in a video, Ebola is transmitted by love. You know, it's family taking care of their deceased relatives. The traditions about how families took care of someone in their family when they died was a very intimate process, and that led to the spread of disease. And so people had to communicate with the people to modify their habits to minimize the spread of disease. And when people adopted those changes in behaviors, they were able to contain the disease and eventually get rid of it in the human population. The unfortunate thing about Ebola is it seems to remain in whatever its animal reservoir is. And so these outbreaks do pop up every once in a while. But once they do, we know what's going on. We can block it.
Okay, what was your opinion or ideas? Do you think COVID-19 was man-made in a lab?
Absolutely not. I haven't seen any evidence of the virus being manipulated in any way, shape, or form. It's the thing we know about viruses and studying their genomes. It's very easy to see that this virus was naturally evolved. The way the mutations are distributed throughout the genome is very indicative, very classic for how viruses evolve naturally. There's always a possibility that there are some technologies out there that we're totally unaware of, but I don't see any evidence from anybody that studies viral evolution that would see any indication of any type of a man-made origin of this virus. Now, one thing that how people use the words about these things. One other thing is it a laboratory-derived virus? You know, what did it originate? And that doesn't mean that it was made in the lab. You know, people work with these viruses all the time, and so there's a potential that maybe the virus had gotten around that way. But again, the evidence doesn't seem to support that. There's no known sequences that are close enough to say that this is came from a specific location. So I say very strongly that it was not a man-made virus. Other than I could say, in a way, man has made it because we've allowed it to evolve. You know, that's been my biggest concern about this virus all along, that it doesn't look like a real serious virus in some of the ways that we're viewing it. But the more this virus spreads, the more it evolves. And the more we let it evolve, the risk. So in a way, by not controlling this virus, we've allowed it to evolve. And so in a lot of ways, society is to blame by not containing it well enough and allowing it to do its work.
So when the COVID is referred to as a China disease, what problem do you see with this kind of speech coming from leadership?
Always with every infectious disease, stigma. You know, every infectious disease we've seen, people have tried to stigmatize some group as to blame, and that's very dangerous. You know, again, we saw this. You know, again, 1980 flu. We called it the Spanish flu. We blame the Spaniards. The Spaniards blame the French. You know, everyone's blaming somebody else and not dealing with the situation. There is really no blame that we should have as far as this. Calling it the China virus, again, kind of belittles what role, again, we all have to play in these types of things. Where it originated isn't the problem. It's where it's propagating. That's the problem. And so I'm very concerned about that kind of terminology. But as some people point out early on, you know, until we knew more about this virus, we were calling it, you know, the Wuhan virus. We were calling it the China virus just because to differentiate it from the other viruses that are being propagated out there. But once we knew and had a name for this, it's really important for society to recognize that viruses are non-discriminatory. They will attack anybody and everybody. And so by labeling it in that way, that's why early on the WHO was hesitant to call this a pandemic. They've gotten away from that locally. What we label these things doesn't help us. It's how we deal with them that's important. So I think we need to look at more how can society better address what we have in front of us rather than what happened in the past.
Okay, it looks like we've got time for one more question. Is the place that the virus originated that important? Why are the countries all trying to avoid being the point of origin for the virus?
Well, no one wants to be the source of the outbreak. You know, so the point of origin certainly is important to recognize and do what we can to contain the virus so it doesn't get to a epidemic stage. As I said, if we're constantly monitoring and surveying all around the world, and when we see a risk of an outbreak happening, contain it where it's happening and minimize it getting spread. And we just have to use the right public health measures. And there are public health measures we know that are effective and other ones we know that are ineffective. So for instance, you know, travel bans can be an effective way in some ways, but whenever you prevent people from doing something, they're going to find another way. And what we find is that when you limit travel, that people are going to go a different way, and we can't monitor what's going on. We need to make sure that we're open and monitoring things and using our best judgment to try and contain things without being oppressive about how that impacts and forcing people to use alternative means to do what they want to do. We see that in a lot of cases right now. So so knowing the source is important, but from the standpoint of how do we help them minimize getting out. I'll tell the story I've told a lot of people. I was in Taiwan when this is breaking out. I was seeing on the local news channels about this outbreak that was happening in Wuhan, China, before it was really being publicly spread on basically New Year's Eve. And people were seeing what's going on, and a lot of people were trying to say, what can we do to go in and help and monitor what's going on to minimize this virus spreading beyond it. But this is a virus that no matter what we've done, it would have gone, it would have spread. It's just, that's how infectious this virus is.
I'm going to jump in. I'm sorry, Dr. Moore. I know that we were wanting to be cognizant of everybody's time, but there was one question. Amy jumped back in from her class, and I thought that it might be a quick one. That how many variants are we currently aware of? They read an article about a meat contracting COVID and the concern of more spread equaling more opportunity for mutations.
Yeah. So we're talking about the SARS-CoV-2. How many different, right? To be honest, we've got 25 million people have been infected in the US. There are 25 million different variants. You know, in fact, within every person, there are variants. So there's variants within variants. That virus is constantly evolving. But what we're seeing is that there are variants that have, that are more prevalent in certain areas. So yeah, so you're right. We're hearing about a variant that we're calling the UK variant. There's a Brazil variant. There is, what I hear, there's a Mexican variant. There is a variant in say meat packing. But again, we're throwing these labels out there because that's where it was first seen, but that doesn't mean where it actually came from. That's just when it was first documented to come from. But clearly there are going to be variants out there that seem to be spreading more widely than all the others. And the variants are generally small parts of the genome. There are other variations that go along with those variants. So what they're doing is focusing on a small part of the genes of the virus, and that's what they're focusing on when they look at the evolution of it. So sorry, that's not a real clear-cut question. There are a lot of variants out there, but I've heard of about half a dozen that seem to be significant variants that seem to be propagating more than we would expect within the population. But we don't have enough sequences to know. You know, again, 25 million people have been infected in the US. You know, we have a few thousand sequences. So we've only looked at, you know, less than 1% of the viruses that are out there. So we can't really make a real clear claim, you know, what is just random chance and what of it is truly a trend.
Dave, this has certainly been a timely subject, and we probably could go on for hours, even days and weeks, as we've been hearing subject. So again, thank you for taking time out of your busy schedule to share your research and your intriguing perspectives. And also would like to continue to thank our audience for participating in these monthly speaker series with us. We have the next one scheduled right now for March 17. So those of us that are losing a lot of sleep, that's an interesting conversation as well. So again, thank you so much. We appreciate your time, and everyone, please be safe and have a great afternoon.
Thanks, everyone. Email me if you have further questions. Take care.